Um, Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter D and F block elements. So any doubts if you have, then please write that in the comments section. And in any other chapter of chemistry, if you have more difficulty, then please mention the name of that chapter also in the comments section. And please install our Sapience education application also, whose um, where we shall upload some important homework questions based on the previous year KCET exam. And the link of the Sapiens Education application is given in the description. So here it is told that which of the following is correct with respect to the melting point of a transition element. So here, so as we know that the melting point of chromium is more than the melting point of manganese. So option D is the correct answer. Then here it is told in which of the following pairs both the elements does not have n minus 1 d n n minus 1 d10 and ns2 configuration in its elementary state. So w- we know that the group 12 elements, which are zinc, cadmium, m- mercury, and Cn, they all have ns2 n minus 1 d10 configuration in their elementary state or in their ground state, and only the electronic configuration for copper, that is argon, um, 4s2 4s1 3d10, so it is not of the form ns2 n minus 1 d10. So it means that copper and zinc, they, so out of them only zinc has got ns2 n minus 1 d10 configuration, but copper does not have. So option B is the correct answer. Mm. And then stainless steel does not rust because chromium forms an oxide layer and protects iron from rusting. So option 4 is the correct answer. Since why stainless steel is an alloy of iron, carbon, and chromium. So here chromium forms an oxide layer which protects the iron from rusting. So option 4 is the correct answer. Then here it is told which of the following pairs of elements cannot form an alloy. So zinc and copper can form alloy. It can form, uh, but iron and mercury cannot form an alloy. Since iron can't form an amalgam, iron cannot form an alloy with mercury. Now all the alloys of mercury are called as amalgams. For example, when an if an alloy of sodium and mercury is made, then it will be called as an sodium amalgam. So here iron cannot form an amalgam with mercury. So it means that option 2 is the correct answer. Then here it is told which of the following types of metals form the most efficient catalysts. So alkali metals means group 1 elements, and group 2 elements are called alkaline earth metals. They can't form efficient catalysts. So only the transition metals, which are the elements from group number 3 to group number 12, they can form efficient catalysts. Only nickel, palladium, platinum, they can form efficient catalysts. They can form efficient catalysts, and nickel is in group number mm, group number 10. So group number 10, it means that they all are transition metals. Transition metals. So option 3 is the correct answer. Then here it is told a transition metal ion exists in its highest oxidation state. It is expected to behave as such. Suppose, for example, in KMnO4, in potassium permanganate, in so here we can have the permanganate i- ion. So the permanganate ion uh, is written as as MnO4 minus ion. So the permanganate ion here, Mn is in +7 oxidation state, which is the highest oxidation state. So it can behave as a very good oxidizing agent. So hence, when a transition m- metal ion is in its highest oxidation state, it can act as an oxidizing agent. Option 3 is the correct answer. Then it is told the highest magnetic moment is shown by the transition metal ion with the configuration. So as we know, the magnetic moment mu is given as root over n into n plus 2 Bohr magneton, where n is the number of unpaired electrons. N is the number of unpaired electrons. So now it means that if the number of the unpaired electrons increases, then the magnetic moment will also increase. So now in 3D 2 electronic configuration, here the number of unpaired electrons is 2, and in case of 3D 5 electronic configuration, here the number of unpaired electron is 5. Since we know that the d subshell has got 5 o- orbitals, the 3D subshell has 5 orbitals. So when we have 3D 7, then it means that here two orbitals will be fully filled and three orbitals will be half filled. So here we will have three unpaired electrons. So 3D7 has got three unpaired electrons, so n is equal to 3. In case of 3D9, here we will have only one unpaired electron. So hence the highest number of unpaired electron is in 3D5, so it will have the highest magnetic moment. So it will have the highest value of mu. So option 2 is the correct answer. Then it is told that the atomic numbers of nickel and copper are 28 and 29 respectively. So the atomic number of nickel is 28. So the electronic configuration for Ni2 plus, that will be equal to argon. Since why the electronic configuration for argon is this only 1s2, 2s2, 2p6, 3s2, 3p6. So it means that Ni2 plus is argon. So argon, it is the atomic number is 18. The atomic number of nickel is 28. So Ni2 plus will have 26 electrons. So it will be argon 4s2 and 3d6. And Ni2 plus means it will be 4s0 3d6. So now and Cu plus, it will have 28 electrons. So it will be argon 4s0 3d10. Since why the electronic configuration for copper is argon 4s2 4s1 3d 10, and the electronic configuration for Cu2 plus, that will be argon 4s0 3d 9. So it means that this given electronic configuration, it is for Cu plus ion. So option 1 is the correct answer. Then the electronic configuration for Cr3 plus is, so Cr3 plus, so as you know that uh, the atomic number for chromium is 24, so Cr3 plus will have 21 electrons. So Cr3 plus, it will be its electronic configuration is argon uh, for, so it will be 4s0 and 3d 3, 4s0 3d3. Since why the electronic configuration for chromium will be argon 4s2 4s2 3d4, or I can say it will be 4s1 3d5. So for Cr3 plus, it will be 4s0 3d3. So option 3 is the correct answer. Then it is told that in the periodic table, metals used as catalyst belong to. So the m- metals which are usually used as catalysts, they are nickel, palladium, and platinum. So they are in group number 10, and they are in the D block. So they are the D block elements. So option 3 is the correct answer. Then the formation of colored solution is possible when metal ion in the compound contains unpaired electrons. So as we know that colored solution is formed when uh, DD electronic transition happens, or I can say FF electronic transition happens, either in the D block elements, means either in the F block elements or in the D block elements. So it will happen only if there is uh, uh, partly filled there is partly filled F orbital or partly filled D orbitals. It means that they should be half filled, or they should contain unpaired electrons. So if unpaired electron is there, then only colored solution is possible. So option 2 is the correct answer. Then here it is told which of the following forms a colorless solution in aqueous m- m- medium. So if there are no unpaired electrons, the rule is that if there are no unpaired electrons, it, it it means that all the orbitals are fully filled, then the solution of that ion will be colorless. Then the solution of that ion will be colorless. So here the electronic configuration for Ti3 plus ion, so that will be argon 4s0 3d1. Since why for Ti, that is titanium, for uh, titanium the atomic number is mm, 22, and argon atomic number is 18, so we need more 4 electrons, so it will be 4s2 3d2, and since it has lost 3 electrons, since its charge is 3 plus, so it will be 4s0 3d1, so it has one unpaired. electrons. So it will give colored solution. It will give colored solution. And in Sc3 plus, in scandium 3 plus, so the atomic number of scandium is 21. So its electronic configuration will be argon 4s2 3d 1, and since it is 3 plus, so it will be same as the electronic configuration for argon only. So hence here there are no unpaired electrons, so it will n- not give colored solution, so it will be a colorless solution it will give. So option 2 is the correct answer. And here also we can see that the electronic configuration for V3 plus, which is uh, vanadium 3 plus ion, so its electronic configuration will be argon. Now the the atomic number of vanadium is 23, so it will be 4s 0, so it will be 4s2 3d 3. So here it will be 4s2 3d 4s0 3d 2 here. And so here it has two unpaired electrons, so it will not give colorless solution, it will be a colored solution. And in case of the fourth one, that is Cr3 plus, as we know, Cr3 plus ion will have the electronic configuration argon 4s0 3d3. So here it has three unpaired electrons, so it will also give colored solution only. Then here it is told to find the IUPAC name of Na3CONO2 whole 6s. So it is sodium hexanitrito. Since here 6 NO2 ions, 6 NO2 ions is present here, and since it is Na3CONO2 whole 6, so it means that, as we know that here NO2 minus ion is used, so it is the nitrite, or I can say nitrito ion or nitrite ion. And so since it is Na3, now Na will have plus 1 charge. So it means that it has cobalt CONO2 whole 6 3 minus charge here. So it means that cobalt will have 3 plus oxidation state. So hence it is sodium hexanitrito cobaltate, and the valency of cobalt is 3. So I should write 3 in the Roman numbers. So it means that option 2 is the correct answer. Then here it is told the metal present in insulin is. The metal present in insulin is zinc. So option 3 is the correct answer. So hope all of you have understood the solutions. Still any mm, doubts if you have, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. Also, please install our Sapience education application, where we shall upload some important homework questions based on the previous year KCET exam on every chapter of chemistry, including this chapter on D and F block e- elements. So thank you everyone. Bye.